Go ahead and get started. Thanks everybody for coming here today. I'm going to be talking about the chain of command, building trust across public sector software supply chains. For whatever reason, in the space of secure software supply chains, we have really long names for everything, so there's not enough room to put SSSC and spell it out. And it's debatable how many S's should there be, how often are we not talking about software supply chains. I will not talk about physical supply chains at all, so if I just say supply chain, assume I mean software supply chain. One thing for this talk, the talk is primarily based off of a bunch of work that was done from the public sector community group under the CNCF, which includes a bunch of other people that did work on this that was not me. So I didn't do all this by myself. And in fact, mostly what I did was come in at the end to just help with a couple of the architecture diagrams. With that said as well too, there's a bunch of architecture diagrams in this that might be really hard to read, but I'll have the slides on Sketch afterwards, so you'll be able to get those as well too. So a little bit about me. First off, dropped out of college twice. Eventually, after the fifth college, I got a degree. So you can do it too. It's all right. Right now, I'm currently a security consultant at ControlPlane, where we specialize in cloud-native security, Kubernetes, and supply chain, AI. We're doing a lot of the new and emerging technology for a lot of really large customers. I'm also a maintainer for a couple projects underneath in Toto, Witness and Archivista. Witness is as you can guess maybe by the name, Witness observes processes to create in Toto attestations, and Archivista stores attestations in a centralized repository, and then it creates a graph out of the subjects of those attestations so you can search across all the attestations that are stored. SBOM is a project under OpenSSF that is able to generate SBOMs from in Toto attestations, and so by looking at things like the build process itself, we can pull different pieces of information out of that and put them into SPDX or CycloneDX format. And then the update framework is a specification, and there's a few libraries around doing secure updates. There's a variation of the update framework, or TUF, called Uptane, and that's used in anyone who has over-the-air updates in your car is probably using some version of TUF. I'm also a tech lead for tag security and compliance in CNCF. We do a lot of work with security assessments of CNCF projects, and we have things like the Supply Chain Security Working Group, and right now there's an initiative around trying to set up some infrastructure for centralizing supply chain metadata for CNCF projects. And I contribute to a handful of other things within each of those ecosystems, like the Salsa project and others. All right, so supply chain security. We have vulnerabilities still. We started talking about this when SolarWinds started in 2019 and to the beginning of 2020, and you would think, 5 years later, we'd solve all the world's problems, but didn't quite happen. We're still seeing new and even sometimes novel attacks. The number of attacks that are the exact same as the ones we saw 5 years ago is disappointing sometimes, but hopefully we're getting better at preventing some of those things. XZUtils is one that happened last year. There was a sort of a social engineering campaign against a burnt-out maintainer. A bunch of people yelling at them saying, we need these security fixes now, your widely used dependency is consumed by all these really important projects, you need to do a better job. And they said, no, I can't, I've got too much going on. And this really helpful person volunteered to remove some of that burden. It turned out that they helped really well at first, and over time it turned out they were a nation-state actor who put a backdoor in the project. That's not great. TJ Actions changed files is a GitHub action that many people were referencing in their workflows with the tag. And someone compromised the repository and had repointed the tags at a digest of a compromised version of the repository. So without making any updates to your workflows whatsoever, all of a sudden, the next time they ran, they started using a compromised version of an action. So pin your dependencies. You should always make sure you do that, please. Last week, at the end of the week, it was Thursday or Friday, people started noticing someone has taken out the domain GHRC instead of GitHub Container Registry. They typo squatted the R and the C. And in this case, they implemented just enough of the OCI API for container registries to be able to receive your credentials. If you go to this URL, you'll get the default Nginx landing page. It says, welcome to Nginx. And you can do a Docker login. They will happily take your credentials, but you can't push or pull any container images from it. I don't know yet who is behind this, but it's there. If you have a typo in your workflows as you're iterating on trying to build a new CI/CD system or something like that, you will end up pushing your token for GitHub Container Registry or whatever else to this. Hopefully you're using a short-lived token and it will expire as soon as the job is finished and people won't be able to do anything else with it after that point. But the great part about HTTP is they could just sit there waiting for 5 minutes or however long until you hit a timeout from the Docker login and do whatever they want to with that token. So long story short, we can't afford to ignore these sorts of issues. It was estimated in 2023 that it cost $45 billion to deal with all these compromises, and it could go up to $80 billion by 2026. So it's not getting better, it's getting worse. And hopefully we can do something about that. And people are doing something about that. And we can see a bunch of the open source package repositories are integrating different pieces of supply chain security technology directly into the package repository itself. So all of these repositories, PyPI, RubyGems, NPM, and Rust crates support trusted publishing. So the idea of being able to have a connection for the artifact that's being distributed from that repository and the source code. So when you think of something like having GitHub or GitLab repository with all your code for a PyPI package or a RubyGem, how do you know that the source code repo is the one that put the package there? And so with trusted publishing, you'll have a signed, verifiable attestation that actually proves the connection between the two things. The other part here is repository hardening. So PyPI and RubyGems are both starting to adopt a project called RSTUF, which is the repository service for TUF. This allows you to protect against things like malicious repository mirrors and things like that. So there's signed metadata that shows what are the set of packages and sort of the directory structure underneath that repository, and ensures that even if someone compromises a mirror, you won't be able to, or just host a malicious mirror, you won't be able to trick a client into trusting information from that, because they won't be able to compromise the signed metadata that proves or lists out what you should trust from that repository. And then just more generally across the open source ecosystem, we're seeing continued increase in adoption of the SigStore project for signing container images, signing SBOMs, all the different types of supply chain metadata that you could create. GitHub now has a first-class entity for attestations. So the Homebrew project is a good example. You can go to github.com/homebrew and then do /attestations, and you can see all the attestations. They produce an attestation for every single bottle that they build themselves. And implicitly, if you do a brew install, you have used in toto. So thank you all if you've used brew. And the really good part about that is there is no user involvement. It just happens by default implicitly, whether you know it or not. And that's the sort of integrations we need in order for supply chain security to go from costing $80 billion next year to hopefully costing much less, because it's still hard, but we can do things to make it easier. So compromises to come. This is an interesting one. We saw XZUtils. It took 3 years of a really long campaign to be able to go from becoming a maintainer on a project to putting a backdoor. Since that 3 years ago, how many other projects right now have a maintainer just lying in wait to compromise? We don't know. And I can guarantee you, though, there's at least there's more than one. How many, we will not know for sure until some point in time in the future. There's an interesting example of this here in Go, the Go ecosystem, a library called EasyJSON. And it turns out that EasyJSON is a part of is underneath mail.ru, and .ru is Russia, which is a subsidiary of Gazprom Media, which is owned by this guy called VK. And it turns out that VK is Sergei Kiryenkov, and he is closely associated with the Kremlin and other things that are terrible. I'll just shorten it to that. The project here that had the issue asking about whether or not they should use this library was Kubernetes. So you can imagine a project at that scope and scale. Another consumer of this library is most of the Sigstore ecosystem. They did a bunch of audits of this library to make sure that everything was okay. It's mostly unmaintained, but who is going to know, who's going to check and do that same set of research 2 years from now when we all forget about this and they do push out an update? So if you're using Go and you're using that dependency, I would maybe look to move to another one. All right, so the reference architecture, the guide from the public sector working group, is based on the CNCF tag securities updated paper on supply chain security best practices. The main point of the public sector user groups one is to look at the specific and unique concerns for public sector. But you still have the prerequisite knowledge of all the other supply chain security best practices that you should be looking at. So we'll just take a quick review kind of that. And the tag security guide goes into kind of a structure here that has the things that you need to secure that are a part of your supply chain, things like the source code, the materials. This is, it refers to your source code kind of as first-party code, and materials, whether they're dependencies or third-party software as second and third-party software. So there's software you get from somewhere else or source code you get from somewhere else that's not your own code. And then the build process itself, the artifacts that are produced from that build process, and then how do you distribute that software, how do you deploy it. And for each of these, we kind of looked at some themes around the verification of each of these steps. How do you know what you expected to happen actually did happen? How do you prove that it happened, not just check it manually, which leads into the automation piece of it as well. Human beings have never, ever made a mistake, right? Sometimes we do, sometimes we mess up, sometimes we drop out of college a couple of times. We can automate a bunch of supply chain security stuff though, and so wherever that's possible, you absolutely should do that. There is a couple of these sections that have guidance around controlled environments, we called. It is really how you should configure services that are a part of your supply chain. So in the case of code, how should you configure branch protection rules for GitHub, or how should you do that same thing for GitLab? What are the ideas or concepts behind that, like branch protection? Should you have signed commits required on the server side, because you can't enforce things on the client side. The build process, the same sort of thing. If you're using a hosted build service, how do you know as a developer, as an organization hosting the build service, how do you know that the right set of people have access to it? Hopefully nobody can interfere with the build process. As a developer, you want to know, how do I trust this build system? How do I know what I expected to happen actually did happen? And then authentication, authorization, big emphasis of the updated guide from Tag Security was around machine and workload identity. So we've seen that become much more common, much easier to consume, especially if you're using some sort of hosted build service, to be able to use those short-lived tokens and identities to sign all the different pieces of metadata that are being produced. All right, and then just, kind of here, looking at the changes from the original guide we wrote in 2021, you can see we had a lot more references to identity. VEX, which is vulnerability exchange, didn't exist in 2021, so the new guide has 20 references to that, and is huge spike towards the end of policy and attestations. And so, originally, there wasn't as much supply chain metadata being produced. Hopefully now there's a large enough set of tools that it becomes much easier to do. And speaking of open source projects to help assist with this entire journey, there's a lot of them. And this is a good thing, and part of the problem is there's lots of tools that you can use. They all do, some have overlapping capabilities. You have to kind of stitch all this together and build a system out of it to really help with the supply chain security. And so that's kind of a good reason to have and produce a reference architecture, but we hopefully still can make it easier for folks. So just kind of a quick overview of some of these projects. We have starting up over here under in toto, SBOMIT, which is a project I mentioned earlier, Archivista, Witness. The red one there is Salsa, which is build provenance. They're starting now, there's a track under Salsa for source code, so kind of how you create attestations and prove that you're managing your source code the right way. RSTUF we mentioned with the repositories. Guac down in the bottom left here is the graph for understanding artifacts, and that really looks at your dependencies, the different things that come from SBOM or other types of attestation, to be able to visualize, understand what is the software, what are the dependencies you're using, are there sorts of things that don't look right. If everybody in your organization is using one version of a library and there's one team that's using a version that's 10 years old, maybe you could find that one team and go talk to them and help them, move to the new version and fix things up. The next sort of series here of the goose icons or logos are for a series of OpenSSF projects. The first one is OpenVex, and so that's the vulnerability exchange. This is kind of the API for, and there's some tooling there for generating VEX documents. So as you have things like vulnerability scan results that come back with false positives, or they're not applicable to your software, for whatever reason, you can actually tell people that, and you can communicate that in a machine readable way so that other systems then can process that information and hopefully not bug you about the fact that these results come back. The next one is Protobomb. This is a project that helps translate and convert between Cyclone DX, SPDX, and back and forth. And so they kind of established mapping between the two. And this is used in a variety of other projects, like the next one, which is bombctl. And so this lets you perform different types of manipulations to SBOMs. If you have a bunch of different SBOMs that go into a new piece of software that you're building because you have an SBOM from every dependency, how do you actually merge all of those together? bombctl is a tool that can help with that. And then the next one here is S2C2F. Remember, I talked about those really long names. This is the secure consumption framework for secure software consumption framework. It's basically a set of practices and guidance around consuming open source software and other pieces of software. What are the questions you should ask? What are the things you should be automating, verifying in order to have confidence in that software that you're using? And then the parachute here with the little Git logo is a project called GitTough. This is a really cool project because it has no, a lot of things we talk about now when we say Git, there is a presumed thing from a a lot of the foundation work and open source in general, that people are just using GitHub or GitLab. We know things like the Linux kernel are not using either of those. And so GitTough stores all of the metadata it creates in the reference state log of the Git repository, so it's not dependent on anything on the Forge side. What it does is it allows you to create policies for your expectations of how you should be managing the Git repository. Should everyone be signing their commits? Should they be pushing directly to branches and then merging that down into main? Or are there certain people who should be doing different things? And then it can verify those expectations in the policies and establish checkpoints. So if you're a project like the Linux kernel and you have millions of commits over a very long time, you don't want to have to verify all of those every single time you verify this Git policy. And so being able to just go back to that most recent checkpoint and then go forward from that point in time is much easier. And then the SigStore project here, we have these show up in the reference architecture that we'll go over in a minute quite a bit. Cosign can sign container images, and it can sign attestations. Fulcio is the certificate authority for these workload identities and signing that's used by Cosign. And then Recor is the transparency log to store information about the certificates that were issued and the artifacts that were signed. So the kind of the progression from the original supply chain reference architecture was some follow-on work that was the secure software factory reference architecture. And once again, this one was more generic across hopefully a broader set of software factories, not necessarily specific to public sector, but it was a good building block for this work. The other was a project called Fresca, which is another really long name, Factory for Repeatable Secure Creation of Artifacts. This is a project under OpenSSF, and it used Tecton and a bunch of other projects from the Linux Foundation to kind of implement the secure software factory. Then, in the US, we had the Executive Order 1428, which specified two main things. One was anyone who sells software to the government has to provide an SBOM with that software. And the other part eventually became the SSDF, which was the Secure Software Development Framework. This actually referenced and cited the TAG Security's Best Practices Guide for Supply Chain Security. So that was really cool to see that people actually read the guidance. At least a few people did somewhere. Another one that came out that was really interesting, just came out last year, was NIST 800-204D. This has specific guidance around best practices or sort of controls you can put in place around CI/CD and what sort of patterns you should look for there. All right, so that was a lot of stuff about general supply chain security. How does this actually relate, or what's different about public sector? So there are some common and unique concerns in this case. If you're a really large organization, enterprise that makes billions and billions of dollars a year, you're probably under some sort of nation attack at all times. If you're a government, you also are probably under the same thing. The difference is people aren't trying to just steal your money. The regulatory frameworks and requirements, the similar sort of thing. There's a ton of effort that goes into just proving the software you've produced and you want to run is actually allowed to run. And that's hard to do, it takes a long time to do, and can be really expensive. And then that affects small organizations, smaller businesses that would love to be able to sell to the government, probably have more innovative software to provide, but it's harder for them to overcome those hurdles because of these things. Air-gapped environments, this is another one where whether you're moving from one isolation level to another, or you have some sort of edge environment because of the requirements of how you're deploying the software, this is something that we don't really cover in the original guide. And then the other, we talked about the SigStore project. That is a public good instance. Anyone can go and publish signatures there. They can publish their attestations. people don't always want to share that information freely everywhere. And so it's, it would be good to have some alternative way to share that sorts of information privately to the set of people who should be able to see it in a way that you're more comfortable with. And then cost is always a concern. So what can we do about these things? Well, I think one of the things that is important is, unfortunately, the regulations we just said are hard, because you need to raise the bar for everybody because they won't do it on their own. We would love everyone to do security for the sake of security, but it's expensive and it's time consuming and it's largely just considered overhead. So if you don't require and mandate that people do this, a lot of times they just won't. And so, we're seeing progress in that direction. Hopefully, we see enforcement as well. I have a little more confidence in the CRA helping, raise the water for everyone. One of the other pieces here is how to federate trust. And so we talked about not having this non-public root of trust. How can you share a certificate or delegate authority for something that should be private through sort of a centralized but federated way, so that a government or an organization can allow different providers of software to sign and attest with their own identities that are provided to them that can be trusted based on that information, and then update that without too much overhead. And then shared infrastructure, audit ledgers. We have the public good instance of SigStore that's running and operating. It would be really good for the government organizations as well to host a version of this for software that is consumed by the government that has some of these privacy concerns addressed. And then just raising awareness and support for open source tooling to do this. So we talked about the fact that all of the compliance and the regulations and the requirements around this make it hard for people to do, but also hard for small organizations to do. If we have free tools that are open source that enable this to be done easier, hopefully we can lower that barrier of entry for other organizations to be able to participate in this. All right, so this is where all of these really small architecture diagrams come in here. And so I'll try and describe them as well, and the slides will be available later. But the high-level overview here at the top, we kind of have the suppliers of software and the different steps they should go through to be able to create the software and verifiable metadata about that software, the thing that we want to use to establish trust between them and the consumer of that software. And then in the middle there, we have the mechanism for sharing the artifacts and information about those. And then down at the bottom, how do the consumers actually verify that, but then how do they have to promote that after they establish trust so that it can be consumed internally, which is the relocate part. And then they're probably going to use that software for something. If it's an open source dependency, they're probably using it to produce new software. And then that new software should go through the same process that the producer did at the very top. So from a open source signing infrastructure, how could this be set up? We have here kind of on the left the identity provider for authentication. KeyCloak is a CNCF project that does this. And then at the top right here, we have Fulcio and Recor being able to create those code signing certificates that can be used. And these connect with that identity provider. So it could be your CI/CD pipeline or a human being, perhaps, who's signing a document. we want to automate as much as possible, but then also sometimes we need to tie things back to the person who did something. The VEX document is a really good example of this. You have a person who did an analysis on whether or not a vulnerability applied to your source code. So if that human being who did the analysis signs the VEX statement saying this vulnerability doesn't apply, you can go back to that person, or you can look at all the other statements they signed when you find out they're a rogue nation-state actor, and you maybe shouldn't trust their vulnerability analysis. And so those sorts of things are made possible through this. One of the other things that the SigStore project has gotten much better at over the last couple of years is enabling offline verification. So the public good instance where many of these open source dependencies are storing all the information, the metadata about what they've produced. You always used to, if you did a verification of it, had to talk to the public good instance of Rekor. And that doesn't work very well if you're in an air-gapped environment. So now they have they call the SigStore bundle, which includes all of the metadata stored in an offline format, so you can transport that across air-gap boundaries or other places and still be able to do that verification. All right, and then the build process. So we have this infrastructure established now for signing things. How do we want to securely build? And it's the long story short is to follow all the guidance from the supply chain best practices guide that we had before. Kind of the example that we have here is your source code repository, going through a secure build process, leveraging things like FIPS to ensure you're using compliant version of encryption algorithms and different things like that, gathering your dependencies, and then this build process, observing it, using a tool like Witness to create an attestation about that build process, using a build service that actually offers isolation between the different build components, not just using one central Jenkins server that has a shared cache between all the different jobs that run. That's a bad idea. It's a good way to allow other people to influence the outcome of your build process. And then once you produce that software, signing it, if you're deploying it, doing a continuous delivery. And then here we can see going into the next piece of the architecture here, publishing that. And so whether it's signing the container images, signing the artifacts that move across, or moving the artifacts themselves. All right, so then once we kind of move down to the next part of this, distributing the artifacts and the trust. So the producer of software will hopefully provide you with the software itself and then the metadata. They should have a signed SBOM, VEX document with that SBOM, talking about the applicability of vulnerabilities that will probably be discovered by a scanner, and then attestations about the different things, a build provenance document, proof that they've done some sort of testing or other sort of analysis. And then, and that attestation as well may be a summary attestation, so you can create a whole bunch of attestations, verify them against a policy, and create a new attestation from that policy verification. So if there is sensitive information about the results of static analysis testing or vulnerability scan or something else, and you don't want to share that, or you have some proprietary information in there, you could have a third party help create that policy, audit the verification, and then sign that summary attestation that is the sort of the final piece that's transported when you distribute the software. And then as an organization consuming this, you're going to want to have your own verification policy or your own promotion policy as well. When do you want to decide to allow this software to be used? Just because someone gave it to you or is trying to sell it to you doesn't mean that you should use it. So what are the checks you want to do to ensure that's actually allowed? Especially, I think, there's probably a higher hurdle just to give you the first version, but how do you make sure that subsequent versions of that software still follow the same standards that originally they told you they were following? So, kind of looking here, blowing up the shared artifacts piece of this for as a sort of standard or guidance, using something like OCI, which is the Open Container Initiatives, you can pretty much put anything into an OCI image these days. Typically, people think of container images, but with tools like ORS and others, you can package anything into an OCI artifact and upload it to a container registry. There's a couple of these in the CNCF, Harbor, Zot, and then the distribution project. Each of these are container registries with different pieces of functionality, but they can all store the metadata, the images, and things like that. And then for the containers themselves, the artifacts, the metadata, the SBOMs, these are all can be in toto for their format as kind of a standard. As far as attestation formats, I'm not really aware of anything other than in toto, so if you do know of anything, let me know. I'd be curious to find out about that. And you can store all those attestations in Archivista. They may come in as a part or attached to the OCI image, but then you could ingest them from that into Archivista. And then RSTUF has an interesting role in this process because you can use that to actually establish trust beyond just the verification. So it's kind of your whitelisting of, or your allow listing of the artifacts you want to be consumed. So when we look at a lot of the new modern identity-based signing, it will verify successfully forever, because what you're verifying is that a certain person signed something, or a certain machine identity, workload identity signed something. And that will always be true. It was always that person or that entity that signed that thing. But should you trust it or not, that's not something that you can revoke. Even though it's backed by a certificate authority, it's a short-lived certificate. And so deciding individually whether or not you should still trust that and storing that information in something like RSTUF is really helpful. And it also allows you to rotate keys and credentials, certificates, things like that over time, so that if you have a compromised version of something, if it's associated with an identity, say I signed a VEX statement and someone stole my email account, signed some VEX statements maliciously, I don't want to get a new identity in order to start signing new statements in the future. I'd like to be able to just revoke trust in those by only placing the metadata and the artifacts you can trust in RSTUF. That allows a separate mechanism. And then consuming this software. So once you start deciding whether or not the producer software should be consumed within your organization, you need to follow the same loop that the supplier had. You're going to consume that, either deploy it or produce more software. You may actually have this loop many times. I mentioned, crossing air gaps, maybe going from a low side to a high side. You have some sensitive information that can't be given to the developers who are writing the application, but then you need to do a little bit more development once you have the data for training a model or the fine-tuning of aircraft information or other things like that, and then maybe eventually deploying it to that edge environment. A really cool tool that helps support a lot of this, this cute little logo at the bottom, is Zarf. That can take all of these things, bundle them up, transport it across an air gap. It actually has its own OCI registry that's a part of it. So as it starts sort of rehydrating things across the air gap, it can stand up its own registry. Then your clusters, if it's a Kubernetes cluster or other things, can pull the software out of that and start running. You can start doing your verification. And then you should be doing this continuously forever. There's new vulnerability database updates. There's zero-day vulnerabilities that are discovered, and you should always be ensuring that things are accurate and still things you should trust over time. And so, diving in even more to, some of the things that maybe are opaque at the producer's side, but now become requirements in order to have the right level of transparency in the consumer, and now evolving into the new producer of software, the things that you should continuously be doing: vulnerability scanning, dependency analysis, policy evaluation, runtime monitoring. Here we can see as your, you have your source code coming in, you have static composition analysis. You can store those SBOMs, other information in tools like Guac or Dependency Track, and you can understand which pieces of software have which dependencies. If you find out that log4j is being used, that's one thing to have brought it into your environment. It's another thing to track down every single application that's deployed to production or in an edge environment that's using that. So there's you need to continue building this chain for your supply chain from ingesting the software to where it's actually running. And so all of these different steps are a part of ensuring you still have that chain continuing to the application deployment itself. And then at the top here, looking at the policy evaluation, whether it's Open Policy Agent, something like Gatekeeper as an admission controller. SigStore has an admission controller called Policy Controller. And each of those, can ensure the expectations you have are actually being met before you deploy software and over time as well. If you have an admission controller that's looking, part of your policy is a vulnerability scan has to have been done within the last 24 hours. Over time, it can start giving you warnings. It's been 48 hours and we don't have an updated vulnerability scan yet. And you can create that metadata out of band from creating the software itself. All right, so that's kind of the whirlwind tour of the reference architecture and what's next. The white paper itself is in the process of getting the CNCF's help to actually get published. It'll be on the CNCF's website. You can join the public sector user group. We're always looking for more people to contribute, to show up, share whatever information you can about the problems you're facing, the technology you're using to solve those problems, and kind of be able to help each other to lower that barrier to entry, ensure that everybody can meet these requirements and help solve these problems together. So there's links here for the, if you go to the community.cncf.io link, you'll be able to register for the meeting that happens every other week. And then there's the GitHub repository as well with links to the draft version of the white paper as well as other things. And if you have questions, you can't make it to the meeting, you can file issues on the repo and things like that, and just have another async way of communicating with folks involved. So with all of that, I don't know if anybody has any questions, because I'm sure that was all completely clear and very simple. All right, well, thanks everybody for stopping by. I'll be around after this too. It's hard to ask a question, a simple question. It's much easier to have a long conversation about stuff too, so I get that. So thank you for coming.